So after reading this question, we see that we have two eagles traveling, one traveling, and we'll say to the right, and one traveling upwards. And their two values are their two vectors are perpendicular to each other. So that means we will have to make a reference chart. So, lost my color. And we will have eagle A and eagle B. We'll call this one A and this one B. And we have an X and a Y component of each. Remember that momentum equals mass times velocity. So we'll have a mass times velocity for both A and B. So in the case of part of eagle A, we have a mass of 4.3 traveling at a speed of 7.8, and its y component will be 0, and eagle B will be 0 since it's going upwards in our diagram, and it will be 5.6 times 10.2. So multiplying these out and then adding them, we will get a resultant momentum of 33.54 for the x direction and 57.12 for the y direction. So the total momentum, if we want to find r, we'll use the Pythagorean theorem. So r will equal 33.54 squared plus 57.12 squared, and we'll take the square root of that answer, and when we do that we get 66.24. So that's the total momentum. Now we know the momentum afterwards are going to be a combined mass, so that momentum has to equal m1 plus m2 times some new velocity. So we'll put our value in here of 66.24 equals the two masses added together, 4.3 plus 5.6 times v, and if we solve that, we will get v equals 6.7 meters per second. So that's how fast they're going to travel. Now we have to find out what direction they're going. So we'll draw a little diagram up here, an XY coordinate system. And we know that we have one going out this way and one going up, and R will be this value. So this is the Y direction, so it's 57.12. And this is the X direction, so it's 33.54. So to find the angle, which is what we're looking for, the tangent of that angle will equal the opposite over the adjacent, so 57.12 divided by 33.54. And on our calculator, we do inverse tangent, and we will get an angle of 59.6 degrees. So our two answers are that angle and that velocity. This is the end of the problem.